Hello, teachers and students. Welcome to Learning is Not Quiet presents the scientific method. Today, I am going to talk all about the scientific method, and I love talking about science and teaching about science, so I'm so pumped that you're here with me. Just a few housekeeping notes before we get started. If you've discovered this video and you're a parent or teacher on YouTube, be sure to check out the description. Links are available there that will help you purchase the worksheets and the other things that go along with this activity, as well as the Prezi that might help you if you're teaching this directly to your students and not in a distance learning context. For students who are watching this video, welcome. And if you are following along either on a digital version of this or a paper version of this in your classroom assigned by your teachers, be sure to pay extra careful attention to words that are in all caps because they're usually the word that fills in a blank or is the answer to a question. So without further ado, let's figure out how scientists do science. So the first step in the scientific method is the question. Every scientific investigation begins with a question. Curiosity is an important trait for scientists, and it is curiosity that inspires the scientific investigation. So some things that scientists ask questions about are like, why is this happening? How would this change if something were different? What would happen if? So a kind of basic example, I have my puppy sitting right here. I was investigating whether or not she could learn to go to the bathroom outside or if it would be better for her to pee on pee pads. I can actually use science to answer that question and figure out things like that. Now, that's a very basic home example. Right now, we're in the coronavirus, and the scientific method is being employed by scientists on the front line who are figuring out the best type of vaccine or what kind of medications work to treat people and their symptoms. So science is used on small scales and big scales every day across all of the countries of the world. And so that's why the scientific method is important. It always begins with a question, and science is always characterized, no matter where it is, no matter how it's practiced, with this fundamental curiosity. So why is this happening? How would it be different? And what would happen if? The next step to the scientific method is hypothesis. A hypothesis is an educated guess. It is what the scientist predicts is going to happen. So again, hypothesis, educated guess. You can use the if-then format to elevate. So the reason we say educated guess and not guess is sometimes students will think they're being silly, and I'll say, let's take the pee pad example. Can my dog pee outside, or is she better off peeing on a pee pad? Some students will give an answer like, an alien should come in, and that's when your dog will pee best. So there are different answers that are correct. You could hypothesize that the dog will do better if peeing outside. The dog will do better if peeing inside. But a not educated guess, something that's out in left field and doesn't really make a lot of sense, is not an educated guess. So it has to actually be possible to happen, and it has to be related to what we're testing. So this if-then format gets away from like, I predict is what's going to happen, or I think, and it really puts it in the way that actual scientists would make a hypothesis. So some examples of that include, I predict that plants receiving more sunlight will grow taller in a 2-week period. If plants are placed in direct sunlight, they will grow taller than plants placed out of direct sunlight. So that one's making it more of a statement and not I predict. I predict that bread dough left to sit for 3 hours will be able to be stretched further than bread dough left to sit for 1 hour. If bread dough is left to sit for 3 hours, it will stretch further than dough left to sit for 1 hour. Okay, so that's our question, and then we're predicting what's happening with an educated guess in our hypothesis. The next piece is to identify the variables. Now, scientists don't literally sit down and go, my independent variable is this, my dependent variable is this, but they organize their experiment that way to make sure that it's fair to the outcome that they're looking for. So, variables. And this is the part that students really get tripped up on sometimes. These are things that you change or manipulate in an experiment. Controls or constants mean the same thing. They are what you keep the same. Note the control group is what you expect to happen. It's basically what you're testing everything against. For example, if you're seeing if a plant will grow in the dark, your control group would be the plant grown in the light. So 2 specific kinds of variables that we have are the independent variable and the dependent variable. The independent variable is what you choose to change in an experiment. It is what you are testing. Again, I always say it's what you choose to change. In an experiment, we're given where we give bean plants different amounts of water, the different amounts of water would be the independent variable. So we want to keep everything else the same so it's fair. We want to change one thing, and the one thing that we're changing is the independent variable. Think about this if we were having a race. So Fred, Joe, and Sam are all having a race. We want to make sure absolutely everything is the same between Fred, Joe, and Sam, except for who they are as a person, right? If I gave Sam a head start, if Joe was allowed to run with running shoes and everybody else wasn't, that wouldn't be a fair race. So if you're thinking about all the different variables as competitors in a race, you want to make sure it's fair for all of them. And the only thing you're changing is what you're actually testing. So in the bean plant experiment, you don't want to give one bean plant more sunlight than the other one if you're really testing the different amounts of water. Okay, so that's the independent variable, what you choose to change. The dependent variable, this is what you're actually measuring. If the plant experiment was happening with different amounts of water, the height of the plant, which one grows more, is the dependent variable. So this is essentially who is winning the race, right? Independent variable is the different people running the race. Dependent variable is who won. Independent variable is what we choose to change. Dependent variable is how we measure it. So the dependent variable in my race analogy would be who won and what time they got. In the plants, it's how high they grow, right? We gave them different amounts of water. That's what we changed. How high they grew or how short they stayed, that's how we measured if that had an effect. Okay. So after we've identified the variables, this is all kind of designing our experiment. We move into actually conducting our experiment. This is the fun part of science, I would say. This is when the scientist puts that hypothesis, that educated guess, to the test. When we're looking at data, data is information that scientists collect during the scientific method about the experiment that they are conducting. There are two main types of data. There's qualitative data. This is data that involves words, has no numbers. And some examples of this would be turned yellow, the bubbles increased, smells like eggs. And actually, in my doctoral studies right now, there's a whole field of just qualitative research where people are not necessarily collecting numbers. They're really looking for the words and the general idea. And a lot of students will ask, like, well, what's an example of a qualitative experiment that we would do? We don't do too many in fifth grade. We really focus on quantitative because it's much easier to compare things objectively with data, but qualitative data can sometimes give us a more robust picture of what's going on. So how people feel about something, how things changed in social emotional behavior. So that's kind of a common question that students have and a good example. So then quantitative data, notice the N there, quantitative data is data that involves numbers. So quantitative numbers. So some example of quantitative data would be it weighs 43 pounds, it has a pH of 7, it's traveling at 3 miles per hour. So we collect that quantitative and qualitative data in our experiment. So just to kind of review, we've asked a question, we made a guess about what was going to happen in our hypothesis. We've created that experiment, make sure it's fair, has only one independent variable, and has a way for us to measure that dependent variable. Everything else is a control. We've conducted that experiment. We've collected quantitative and or qualitative data, and now we're ready for the conclusion. This is the final step of the scientific method. So this is the end of the experiment where your hypothesis will be verified, meaning that it was correct, or falsified, meaning that it was incorrect. Now, being correct in science is not something that we value. In school, we kind of think like, oh, if I know the answer, I should raise my hand and I should get credit for it, and knowing the answer is a good thing. In science, we don't care. If your hypothesis is wrong, it's fine. You're just establishing what you thought before the experiment, and it's okay if what you thought changes. That's a very important concept of science. And so this is where we kind of determine what happened, and we lay it out to the people who might repeat our study or read our study, what happened and why do we think it happened that way. If it's verified, that means our hypothesis was correct. If it's falsified, that means our hypothesis was incorrect. So if you are a teacher using this product, just kind of as an extension, there is differentiation here. This is what the product looks like in general. And this is what it looks like if you are doing it in English in the formal way. There is also a Spanish version available with a Spanish Prezi, and there is a much easier version for students who might have disabilities. Also, if you're a teacher watching this video and you're interested in more products, be aware that there are so much more scientific method stuff, such as this scientific method interactive notebook page. This is kind of what it looks like in the examples. This is also available in Spanish and in an easier version. There's a word wall. There's all kinds of scientific method experiments, PBLs with, stinky pugs like mine that's running around in the background, as well as full bundles of the scientific method. So, students, I hope this was helpful for you in understanding the scientific method. Teachers, I hope this was helpful in giving an overview of what's included and how to use this product in your classroom. Have a fabulous day. Adios.